We'll just give a few more minutes for people to come in and then we'll start. Hello.
Good.
Yeah.
We'll stream it.
Yes. Okay. All right. Am I audible back there? So I'm Anand. I'm from Hartford, Connecticut. So I'm an aspiring data scientist. I work with relational, unstructured, semi-structured data sets. And I try and use different tools we have, open source and licensed, creating ETL pipelines and do a lot of things. So as part of this session, we have 45 minutes to talk about basics of data science. And then this is an activity-filled session. We have a notebook that I have coded, which has an activity, a basic, we'll build a basic machine learning model to classify the tweets, and then we'll see how it happens. So before we start, right, what is data science? I'll keep it short. You must have seen this Venn diagram or a similar Venn diagram somewhere in the internet. So when we talk about data science, we are talking about more than one field. It's not just data. Data science is a continuous process. We try to get insights from the data, and we have to. And the middle picture shows you there is a massive growth in the digital data that's available. So when you're talking about data science, you want tools that can handle massive amount of data every day, and you need mathematical and statistical models to be created and to be applied on data. And the business knowledge comes into picture because you need to understand what questions you want to ask, and you need to have the knowledge to pick the right data set in order to achieve the objective. And why Python? So that's because no other language worked out for me. But Python is easy, and it's absolutely your choice. You can do the same thing in Java, C, C++. It's up to you. But Python has a variety of libraries, open source, and you have a lot of references available on the internet to refer to start with. And after Python, R is again very similar to Python. You have all the libraries that are available in Python. They are available in for R as well. So you can get started with any language you actually want. So these are just useful tools I was putting together because when I started working on massive data sets, these tools helped me in one way or other. Tabula is particularly interesting because it consumes PDFs and it creates a tables out of PDFs. So you can, it's very easy to use and it's open source. And I'll share the deck and also the notebook that we are going to see after the session. So everything here is open source, including Plotly. Plotly has a limit. They have a free version and also the premium version. I'm not sure about the limit, but you can still work with the free version. I've done a lot of things with Plotly for free without having to pay anything. So, and Jupyter Notebook. So the activity for today's session is, again, we are using Jupyter Notebook for that. If you're new to Jupyter Notebook, it's a web application for you to create notebook, a combination of notebook and reference and codes. So it's easy for you to compose everything in just one notebook and share it with others as well. It's easy to collaborate. Machine learning. So before jumping into the activity. So machine learning, it's a continuous process again, and you have different types of learning, supervised and unsupervised, and we saw we saw a variety of data sets in the first slide, right? So when we talk about machine learning, I know what is cat and what is dog, but when you're talking to computer, when you want the computer to classify something, or if you're teaching computer, you need to tell computer that this is cat and this is how dog looks like. So you give hundreds images of cats and dogs saying this is cat and this is dog, and train the computer, and then you give another photo for it to classify. Now, no model is 100%. And what I just mentioned, the example is a very basic example. But machine learning has endless capabilities. And I myself, I'm just getting started with this journey. You have hundreds of algorithms, hundreds of models available for you to use with. And the biggest pitfall, I think, for when you're starting with machine learning is, one, it has a very strong relation to math. You need to be absolutely sure the model you're using is correct, and you need to be absolutely sure the questions you're asking is correct. They are correct as well. And type of learning matters, because when we talk about supervised learning, you're classifying the data and you're letting the model know this is what it is. So you kind of know the output. But for the unsupervised data, the output is unknown. You're basically, I'm talking about TensorFlow type of thing. So it involves a lot. You have to devote a lot of time, energy, and resource to even go for the unsupervised learning. Any questions so far? Am I going too fast or? Right. So that's all I have for the slides. I think we need more time for the activity. Right. The activity we have here is using the NLTK. NLTK is a natural language toolkit. That's a popular package created for Python. It helps you to deal with NLP data, natural language processing data. It's basically human interaction, and it helps you with sentiment analysis and classifying, deriving sentiments out of tweets, movie reviews, or any speeches that you have. So this is again open source, and NLTK has 50 predefined data sets available for you to get started with. They have different types of data. What we'll see today is Twitter. They have Twitter dataset, but they have, I think, variety of datasets available, and they are free to use. So as we go along, I'll explain the logic behind it, and I'll also explain the approach behind this. And before we start, I think it's better if I talk about the approach, what we are trying to do. So we have Twitter dataset, which is from NLTK. And what we'll do is, the dataset, I did not create the dataset, it's pre-created. So you have a positive dataset and a negative dataset, which includes set of tweets. Positive is a JSON file that has some tweets, and negative, same for negative. What we'll do is we'll get the dataset, we'll try and understand what's inside it, and we'll remove the useless words from the datasets. When I say useless words, I mean the punctuations and the words that don't really add any meaning to it, like I, him, is, we. So these are predefined stop words defined for different languages in NLTK. And it's important when you're dealing with natural language processing because you're dealing with human interaction. And when you're talking about creating sentiment, deriving sentiment out of the data set, it's important for you to remove useless words because it can mess up your model, it can mess up your output, right? And once after we clean the data set, we'll create a machine learning model, a basic naive-based model. And the naive-based model is based on Bayes theorem, probability of A happening on the presence of probability of B. So we'll create a basic model using the data set. We'll train the model and we'll test it and see what's the output, right? And we are talking about a very small sample. It's not huge. So, right. So import NLTK to to get started with. You need the package and the Twitter samples, right? This is the keyword that I'm using. So NLTK, so as I mentioned, they have different data sets and they have keywords defined for each data set. So you look at their website to understand what keyword to use to download the data set. So the Twitter samples is what we should use to download the Twitter data set they have. And NLTK corpus is required because that corpus or corpora that has the massive set of all the data sets. So we'll download the data set and the method file IDs. So we downloaded the data set. We want to know what's inside it. For Twitter, we just have 3. So if you have, I think the most popular one that I've seen is movie reviews. Movie reviews has 2, and they also have State of Union from for the past 20-25 years. It's again fascinating because the State of Union address given by different presidents, and they are huge. To even start with, when I started with that, it took me a lot of time to even get down to the model. So I'm using length just to see how many tweets are present in the dataset. So we know we have negative tweets and positive tweets. They are JSON files. So if you're new to JSON, it's JavaScript object notation. And I think each dataset has 5,000 tweets. So yeah, negative is again 5,000. So we can ignore the last one. So we have downloaded the data. We did not create the dataset, but we have the dataset now to analyze. So we talked about useless words. So in order to use useless words, you need to create a list of that. Again in NLTK, you have string, which gives you the punctuation, and NLTK corpus has the method called stop words. Stop words will give you, based on the language you give, it gives you the stop words for that language. So we are getting, for English, we are getting the stop words. So now we have created a list. So now we have created a list of useless words. And if you look at that, the punctuation below and the stop words have all the references. So now we have the useless words, which needs to be removed from the Twitter dataset. Oh, so right. So I think we should have done this before to look into the dataset to understand how the tweet is present or how the data is present. So this is just a sample. If you look into positive or negative dataset, this is how it's present. A list, and you have each tweet as a list, as an element inside the list. Right. Tokenizing text. So when we are dealing with NLTK, we are talking about we are dealing with paragraphs. We don't talk in words, we talk in sentences. So for any NLP operation, it's important that you break down the sentences into words. Only then you can cleanse those, and after that you can use it to do whatever you want. So tokenizing is a mechanism where you break down sentences into words, and NLTK again offers, they have methods which can help you to tokenize the sentences. So what we are doing here is I'm invoking the tokenized method, and I'm giving the positive and negative tweet file, which will tokenize the data. And this is how it will look like. So this is just for one tweet. So it breaks the tweet down into list, and each element is now present as a word. So we talked about cleansing the data. So the first step of cleansing the data is you need to tokenize it because you're breaking down the sentences into words. And second thing is a bag of words model. Okay, so this model is, it's just a set of unorganized text. So you've tokenized the string, you've tokenized the sentence. So you now have all the words available. And what you want to do is you want to remove the useless words from your data set. So we are building, this is just a function that we're building. It returns a dictionary. So if you look at the function, it says it returns the word, whatever you're giving in, and one if the word is not present in the useless word. Right. So we're defining a function and we're just testing the function. So this is the tweet we saw, full tweet, and I'm running the same tweet with this function. Look at the length difference. So you have punctuation, you have words like we, you, but if you look at this, everything is removed. And the function is returning the words with one only if they are not present in the useless words. So now this is how we are going to cleanse the entire data set that we have before building the model. Right. So in order to do that, we have two data sets, two JSON files. So we have to tokenize both of them. So we are writing a function to tokenize both the data sets. And this, so I've included length just to find out after you clean the data set. I was curious to find out what's the length. So initially, without any modification, we have over 100,000 words in the data set. Now I'm using the same. I'm using the same list, and I'm running through the function. So we're almost down by more than 20K. Now this is still, so this is because the Twitter dataset here is created way back. So when the length was just 149. But when you do the same for movie reviews or State of Union, you'll see a reduction at least by 40 to 50%, because you're talking about massive paragraphs and it has a lot of punctuations and a lot of references. Everything will be removed. All right. So most common words. Most common words is useful because when you're creating a model, and we are using Bayes' theorem, so every positive and negative, it'll determine by how many words are coming from each. So we'll look at the output of that later. Now we'll just go through and find out what are the most common words used. Now I'm using the I'm using the package counter. Right. So if you see, the most common words are, so we are doing this for the entire data set, no positive, no negative. So you'll see sad smiley and you'll see happy smiley, you'll see everything. It'll just give you a count. So sad smiley is used 4,586 times, and the happy is 3,600 times. And to understand the frequency of the words, again, this is not required, but if you're curious to understand, if you're dealing again with movie reviews or State of the Union, the vocabulary it'll be big. So you'll find a lot of new words, and you'll not find this repetition. So the curve here, if you see, it's not so flat, it's just straight down. But if you run this through with movie or State of the Union, you'll see a nice flat curve because you have a lot of words, and the frequency is again more. All right, before machine learning, before we start, we'll just recap and we'll take questions if you have any. We downloaded the dataset and we saw how to cleanse it, and we talked about stop words, punctuations, and we built a function to see the most common words used in the dataset. And now the rest is building the model and running your dataset through the model with classification, and then checking the model. Do you have any questions or anything that you want me to repeat before we proceed?
Just a quick
Sure.
context, just for me. Sorry, I think I might have missed it at the beginning.
Sure.
So the NLTK kit, the toolkit, is written in Python. This is all written in Python.
Yes.
Okay, I'm sorry. It's something I missed. I just
Oh yeah,
wanted to
NLTK.
relate to the
All right.
Python.
So NLTK is the Natural Language Toolkit. It's a package for Python.
Oh, okay.
Yeah, but
Sorry, I missed that.
yeah, that's okay. So you should have NLP for other languages as well.
Oh, okay.
So,
Maybe just to set a little more context, could you describe what Jupyter is and how somebody would watch Jupyter? I mean, I don't know if it's appropriate for this talk or not. But
sure.
Just to sort of situate some.
Absolutely. So Jupyter Notebook is a web application. So it's an open source application, and it's easy to install. You just have to download and install. And it supports, as of I know, it supports Python, R, and Julia. It's again a language. So we use Jupyter Notebook because it gives you a mix of, okay, I'll just give, if you look at the dropdown, it gives you a mix of code and reference and the documents. So you can create, it's easy to collaborate when you're talking to a team. If you're like presenting a session, it's easy for you to put everything in one place, step by step, code, comment, reference, code, comment, reference. So you can compose a neat, long notebook, and it's easy for you to compose, and it's easy for others to read and understand. And it also has a kernel built in, which means after you install the notebook, you can run it in your computer, and it's offline. You can run it offline as long as you don't, your operation doesn't really require internet.
I noticed that you've been using on Mac. Did you have to upgrade your Python to version 3 to get Jupyter running, or were you able to do it with 2.7?
Using Jupyter with Python 3?
Yeah, just like, I've been struggling to install Jupyter on my machine. I tried using pip, and I keep running into have the wrong version of Python.
Oh, I use Python 3.
Yeah, I
Python
had the same
2.7?
problem. Jupyter used to allow you to run on old versions of Python,
Right.
and I've only been able to do Python 3.
It's free.
Pip
It's free. If you have to Python 2 and Python 3, Pip 3 goes to Python 3. Pip goes to Python 3.
Okay.
Right. So there's an underlying kernel to it. So when you can execute the code as you just write it, and it's easy for you to save and resume whenever you want. Right. Any questions? So building the model. So again, going back to Bayes' theorem, we have tweets and set of positive tweets and negative tweets. And what we want to do is, before we actually build the model, we have to prepare the data to be supplied to the model. Now, if you look at the functions we are calling the bag of words function. This function was written earlier. We saw where this is the one. For input, it removes all the useless words and it gives you only the filtered words that's required for you. So we are calling the function for all the negative and positive. And we are creating a tuple with, for negative, we are creating uh, with an indicator NEG, and for positive, it's POS. That's because for model to understand these tweets are positive, these tweets are negative. Now, this is required since we are using naive Bayes and we are training the model. And we'll use 80% of the data that we have to train the model, and then rest of the data will be used to test, and we'll see what comes out. Right. So I'm just executing these two, which now they've created the positive features and negative features, and this is how it looks. Right. So this is just a sample for positive features. You have the tweet, and you have the positive POS indicator, and you have the same for negative. Right here. Now we'll import. NLTK has built-in models, and we'll import the naive-Bayes classifier from NLTK. And we have to split the data set. Remember, we have to keep the training data separate from the test data, because you cannot expose your actual test data to the model. You're training the model, it has to have completely a different set of data. So we'll split the data, and 4,000 out of 5,000 tweets are now from each positive and negative. It will be used for training the model, and the 1,000 tweets will be used for actual testing. So here I'm using naive-Bayes classifier to train. If you see, you have positive and negative, and you're using the split to give 0 to 4,000. So you're giving only the first 4,000 tweets. And we calculate the training accuracy using, again, NLTK. It's 99.96. And now the model is ready. At least after the training, the model is ready, because we are dealing with relatively very small and simple data set. So now we can test the model with positive and negative. If you see the range, we are giving after 4,000 for each. So then the accuracy is pretty high. That's because it's relatively simpler, the data set that we are dealing with. So now we have a model which has been trained and tested. If I give any tweet on my own, let's see how it shows. It should either show positive or negative because we've trained it. So it shows negative, and I did not change anything except the smiley. If I change the smiley, showing positive. That's because NLTK has a method, show most informative features. This will help you understand what influences the output. This will tell you. So if you look at the first line, this is sad smiley, which trumps negative, and there's a happy, which is again mostly positive. So for each, it'll show most influential words that's influencing your output and whatever you're seeing. Right now, if you take
The question about that.
Sure.
So there's a weight over on the side, right? And to tell you how informative it is. Has that been derived from using the two data sets? And the count of
this
words
one?
in each data set? Yeah.
Yes. Since we're using Bayes theorem, when you train, it it understands you're passing a tuple. So you're passing a tweet and then an indicator. So for positive, it tries to see how many smileys are present. It tries to match and get the weight. And same, it'll do the same for negative. And then it'll try and understand and classify.
How does it know, how does the classifier know that you're trying to look at that data? Where have you told classifier?
Here. So
Okay,
this is where,
classifier equals
right.
okay. Sorry.
Yeah. So we are importing the classifier, and then you're invoking the method and giving the data set.
Okay. And so it's the training data that it is giving
Correct.
you the most informative information from. And if you wanted to do like training accuracy.
Right. The accuracy is used to measure the understanding of the classifier. And that's it, which is surprisingly short. All right, sure.
One question when I read these probability tables, which I have in the past too, is so let's take the first line. It says the occurrence of frowny face in the tweet. Like the number, the ratio negative to positive, like that sum ratio is approximately 2,362 to 1.
Right.
So that means, what does that actually, so trying to unpack that in my brain, I understand it's probability. So the occurrence of one frowny face. I'm trying to stack these bags of words because the tweet is going to contain the frowny face and maybe some other words. So
there's going to be, looks like 2,362.3 round cases in negative tweets, or maybe one round case that's in positive.
so looking at the bag of words, it looks at all of the words, right? It sort of sums these.
No,
up.
yeah. It looks at all of the words.
Yes. Okay.
Yeah, right.
In the
Right.
tweet.
And so if
In
there
the
happened to be
tweet,
another
because-
factor- sorry, if there was another factor that had approximately, same number, like a 2,000 to 1, but positive to negative instead, would they sort of cancel each other out when we're trying to make a prediction?
No, it'll not. Even if you just do a simple probability by yourself, even you'll just calculate till the end, so it'll not cancel each other out. No. You can just play around with this. Pretty accurate just because it's small. Normally, when you're dealing with massive data sets, the accuracy will not even go beyond 70 or 75 because it's pretty good. I mean, for a model, 70, 75 is good. But again, you're dealing with massive data. So
I feel bad for the user Riley McDonough. Highly correlated.
Right. So you can, Twitter has a free API for you to try this out. If you want to do it on your own, you can. You just need to create an application in Twitter to get access and get the data. And once you have the data set, remember, so we did not create the data set. We did not classify. We did not put positive and negative into it. So we don't even know what's inside the data set. So we're just getting the data set and trying this out. So.
And how have you then, if you have any application of this in terms of, so after you've built this model and then you've done the natural language processing, you trained your machine learning, and then have you tested it on another set, then how are you using this? Like, how would you then take this and use it
Practical.
on your next model, or can you, or how do you extend it beyond this?
So NLP it's very practical. If you see the day-to-day things, Google Home and any devices you have. So that uses NLP, extensive NLP, because it tries to understand what you're saying, and it's impressive because I bought Google Home Mini right after it came out, and I have Alexa too. So compared to Alexa, Google is way advanced in their machine learning. Now, after I think few months or so, I used to say only stop to Google when I wanted to stop. Now, if I say thank you, it recognizes and stops. Yeah. So that's where NLP comes into picture. The practical applications, the IoT, and anything that you're dealing, any human data, the text data you're dealing with, you build a model and you constantly feed the data to improve the model. So yeah. So any other questions? Thoughts? All right. So I can leave my contact here because I can provide these two, so you can. This is Outlook. So let me know if you want access to the notebook and the deck, and also I prepared some other notebooks, but I couldn't actually complete it. So I can share the notebooks, which actually helps you to get started with logging into Twitter, using API, getting the data, and trying out yourself, finding basic analysis, finding out the number of retweets and sentiment based on the trends, location. So you can do that. Right. And thank you for joining. Hey.
You say you're from Hartford in Connecticut?
Yeah.
I'm from Weathersfield.
Oh,
So I'm like,
nice to meet you.
nice to meet you.
Your name?
My name is Nana.
I'm Anand. It's big, but yeah.
How do you say your name?
Just say Anand. It's easy.
Anand? Okay.
Awesome. So you're in Weathersfield. You're studying, or?
I'm gonna go to school in the fall.
Awesome. Okay.
Yeah.
Cool. So you are in the meetup in another
This is the
Hartford?
first time I've been here.
Oh, this is good. Okay, come.
So I don't know any of the meetups in Harvard. I
Okay.
would like to know about them and go to those.
Absolutely, yeah. So let me know. We can.
Okay.
If you're available, we can. There are a lot of meetups happening, but it's not active. So I remember attending a few meetups last year, but now I'm still waiting for it.
Okay.
We can do it.
Yeah, I'll contact you.
Yeah.
Thank you.
All the tools change, and like, depends how you installed it.